got that. Okay, go ahead here, click this. Okay, so welcome for our last day on this lesson. Yay. But that's okay. We've been taking it, slowly but surely. So let's go ahead and let's look at example 5A. I'm going to make it a little bit larger. Okay. So two major things that we're going to be looking at today. Number one, how do you solve for x when x is in an exponent? Okay. And the second thing we're going to be looking at is how do we simplify, multiply, divide, all that with radicals. Okay, so those are kind of the two concepts that we're looking at today. All right, so this one right here, I'm going to go ahead. Actually, you know what? I'm going to do the harder one, and then I'm going to let y'all do the easy one, okay? Because I feel like I'm good. So with this one, the first major rule when you're solving for x and it's in an exponent, all bases must be equal. Okay? Once the bases are equal, then the exponents can be equal. Okay? So this right here, we're looking at, we have a 16 and we have an 8, and I think, what factor do you think they both have in common? They both have what? What can I divide both of them by? You said 2? Yeah, I agree. That's probably the smallest ones, right? So let me go ahead. I'm going to make a tree over here for 16. And I'm going to pull out a factor of 2. So 2 times what gives me 16? Y'all know it? It is 8. Good. Okay. Let me pull this over to the side. And then 2 times what gives me 8? 4. And 2 times what gives me 4? 2, right? All right, good. So basically we got all these little 2's. Would you agree that 16 is probably 2 to the power of 1, 2, 3, 4? Yes? All right. We also have 8. We don't really have to redo a tree for 8 because look, we got 8 right here, right? And look at all the 2's that come off of that one. So would you agree that 8 is really 2 to the power of 1, 2, 3? Okay. Do you see that? Okay. So I'm going to go ahead and replace this 16 and this 8 with one, like the equivalents, right? But they notice how they both have equal bases, right? So I'm going to replace the 16. I'm going to replace the 8. So we're going to start right here. I got 16. Instead of 16, I'm going to write 2 to the 4th power. And I'm going to put all of that to the power of 2x minus 1, right? And then I'm going to replace 8 with 2 to the 3rd power. Okay, so one last thing. Does anybody remember what does this parenthesis with the exponent outside of it mean that I'm going to do according to my sheet? Do you remember? Let's look for it on the sheet. Do you see the one with parentheses? There you go. Good job, Becca. All right, see these parentheses? Yes, you're absolutely right. It's multiply. Because look how you have the parentheses with an exponent right outside of it, right? So that means, and then it tells us that we're going to multiply our exponents. So that's exactly what that means. So I'm going to go ahead here and rewrite this so that it's 2 to the power of 4 times 2x minus 1. And that's going to equal 2 to the power of 3. Any questions? Are you with me? Ezra, dear, can you take off your headphones, please? Thank you, dear. So now that our bases are equal, let's go ahead and set our exponents equal. And we have 4 times 2x minus 1 equal to 3. Go ahead. On how would I solve for x? It's been a little while. Do you remember? What would be the first thing we would do? 2. The parentheses, yes. Remember the steps are S, A, D. S is for simplify. We don't want any parentheses or any like terms, right? And so we're going to distribute. So we're going to distribute the 4 times the 2x, distribute the 4 times the -1. I'm going to go ahead and write it up here. 4 times 2x is 8x. Yes. 4 times -1. Feel free to shout it out. -4. And then this equals 3. Everybody still with me on that one? It's been a while, but we remember. All right, what is the very next step to get x all by itself? Jamali, do you remember? Or you want a lifeline? Okay, so we're going to deal with this -4. And I had a lot of people respond, hey, well, we're going to do the additive inverse. It's the next step, right? Additive inverse, where we do the opposite, right? And we add 4, and then we add 4, right? So we have 8x. That goes away. Equals 3 plus 4, which is 7. Last step. Last step. Divide, and we divide by 8. Good job, y'all. So x is equal to 7/8, and we're done. Y'all see how that works? Okay, so I did this crazy complicated one for you guys, and here's this nice easy one. My suggestion is get the bases the same. Here's your hint. I would suspect this is probably divisible by 9. Okay, that's your hint. Make your little tree. Okay, if you're watching the video right now is a great time to hit pause and see if you get it. I'm going to go, and good job to Jacqueline. Very nice. Ellen Line, very good. And Miss Emma as well. All right, so good job, y'all. Let's go ahead and let's take a look at this. If we did this and we took it and broke it down by 9, right? And the reason I did that is because this is already a 9, so that would be a little less work. So 729 divided by 9 is 81. And then if I divide that by 9, I get 9 again. So 9 times 9 times 9 is this, right? So would you agree that this would be 9 to the power of 3, right? Okay. So I'm going to go ahead and rewrite this. 729 is equal to the power is equal to 9 to the power of 3. I can take out the middleman. Hold on. I wrote my x too low. And if my bases are the same, then my exponents will be the same, right? X will equal 3. Do you see it? Now, let's say that you were one of my overachievers and you said, I'm not stopping at 9, I'm going to 3. Okay. Then let's count our 3s. We have 1, 2, 3, 4, 5, and 6. So this could also be equal to 3 to the power of 6. Do you see it? And if I did that, then I'm going to start off with my equation again, right? I got 9 to the power of x is equal to 729. We said that 729 is equal to 3 to the power of 6. Okay. Now, the only problem is that 9 does not have a base of 3, right? That's okay. We could look at our tree and we actually see it. We don't have to make a new tree. 9 right here is 3 times 3. You see it? So would you agree that 9 is also 3 to the power of 2? Yes. That little exponent on top tells you how many times you're multiplying the base by itself. Yes. So we got 2 3s, so that means 3 to the power of 2. Does that make sense? Cool. So what I'm going to do is I'm going to replace that 9. I still have the exponent of x, but I'm going to go ahead here and I'm going to put 3 to the power of 2. What did we say that parenthesis meant according to our star sheet? I'm going to go over here. What did the parenthesis mean? Multiplication, right? So I can look at there and say, oh, I got to multiply because I got that parenthesis. So I'm going to go in here And that's 3 to the power of 2 times x equals 3 to the power of 6. My bases are the same, so now my exponents can be the same. And I can divide by 2, and x will equal 3. Questions? All right. Good. I liked a lot of the work that I saw. It was really, really good. Okay, guys, we are finally done with that one. Shake it off. Woo, let's go to the new one, okay? So, did anybody need more time with this one? No? All right. Let's go ahead. We're going to look at this one right here. And this one is just simplifying radical expressions. I mean, the title pretty much is what we're going to do. We will simplify. And yeah, we will simplify expressions with radicals, I guess. Okay. So let's go ahead. Let's look at this first one. Now, we've been talking about radicals this week, right? What is the ninja index? The one that we don't see. It is a 2. Sonia, I'll get you one in just a second, dear. I'm sorry. And then we have a 2, right? It's the only ninja that's not a 1. Usually all the other ninjas are 1. Like, for example, the exponent here, we assume is 1, right? Okay. So what does this actually mean? Okay. Well, let's go ahead. We're going to expand it out. Okay. We got 32. 2 times what gives me 32? Anybody know? 16. Yay. Half of 16? 8. Half of 8? 4. And half of 4? 2. So 32 is equivalent to 2 to the power of 2, 3, 4, and 5. So I can rewrite this so that I have 2 to the 5th power, right? And I can also rewrite it and expand it out. I have an index of 2 that tells me how big of a group to look for, and then 2 to the 5th power, 5. I'm going to multiply 2 by itself 5 times. Okay. Is it 2, 4? Well, it's actually like, see, 1, 2, 3, 4, and 5. Yes? Okay. So what we're going to do, I'm looking for those groups of 2. Here's a group of 2 factors that are the same. Another 2 that are the same. Okay. So when we talk about exiting the radical, okay, this number right here tells us how big the group is. So boop, out pops a 2. Yes? And that one is no longer. Right here, we have a group of 2. Boop, out pops another 2, right? Out from under the radical. How about this last 2? Does he have anybody to play with? No, he's got to stay home. Okay, keep in mind, it's still multiplying. Index of 2 and a 2 that stays home. Let's clean it up a little bit. 2 times 2 is 4. We don't need that ninja index. We assume it's there. And we don't need that extra multiplication sign because that 4, we assume it's multiplying. And this is our final answer. Okay? Let's look at this one. Now, I feel okay that y'all could do the 9, but my hint to you is going to be this. X to the 3rd is the same as x times x times x. So I would write a radical and expand everything out, okay? All right, let me go ahead and give you a little time to do that. We'll pause. So here, so we know that 9 is also equal to 3 times 3, right? And let's go ahead. We're going to write our radical and just kind of expand everything out. We have a ninja 2, okay? And instead of the 9, I'm going to write 3 times 3. And instead of x to the third, I'm going to write x times x times x. Now, my 2 tells me that I'm looking for groups of 2, right? And I have a group of 2 3s, right? So what's going to pop out is a 3. A 3 will pop out from under the radical. No longer. He is free. Now we have another group of 2. We have a group of 2 x's, right? So an x is going to pop out. And we have 3x, okay? Please notice that this 2 is only for telling me about the size of the group, right? It doesn't actually get included with anything else. Then how about this last x? He stays home. You don't have a date. He stays home, okay? And we're done. Questions? All right. Good, Jacqueline. All right, let's go ahead. Let's look at this next one. We're going to multiply radicals, okay? So that's like everything's kind of multiplying. It's all squished together. If we have something like this, we can put it under one big giant radical. This is the same as we have 6 times 6, right? I have a ninja 2 right here, so I have a group of 2. And what's going to pop out? A 6, and we're done. Easy? Let me give you a little tougher example. What if I had something like this? Let's say I have like 2 square root of 6 times 4 times the square root of 6, right? So if we have something like that, if it's not under the radical, we're not going to put it under the radical, okay? Everything here is multiplying. We got a little multiplication here. We got a little multiplication there. So let's pull out our big numbers that are up front. We got 2 times 4. We're going to rearrange them and pull them up front. Now we have a radical. We're going to put 6 times 6. Okay. So in my radical, we have a ninja 2. So we are looking for groups of 2. And what's going to pop out? A 6. And then I can clean it up. 2 times 4 is 8. And 8 times 6 is 48. And we're done. Y'all see how that works? All right. Now I'm going to give you this super hard one so that you can do it since I did 2 super easy ones. Yes? Go ahead and give you a moment. All right, so here we talked about how we organize it, right? The 3 was never under the radical. That's the only thing that goes outside. And then everything else was under the radical. We kind of group them together. We have a group here, a group there. And by the way, for those of you online, okay, good. Thank you for sharing with me. So the 7 does not have a group of 2. There's not 2 7s. So that one's going to stay home. I like to think of this as a little house. Okay. Now I have the 3. He was born outside. He's going to stay outside. I have a group of 2 x's. So the x will pop out and it's just one x, right? If I have a group of 2, only one of the factors pops out. And then again, the same with the y. And ladies and gentlemen, we are done. Any questions on that? Okay, let's go ahead and let's look right here. We're going to use the quotient properties of radicals. Quotient is just a fancy word for divide, right? So if you have this, you can actually split it up. Now I know that 13 is a prime number, right? There's nothing like 2 times anything that's going to give me any factors. I can't really do a tree with that. So we're pretty much stuck, okay? But the square root of 10, does anybody know what the 2 factors for 100 is? I'm sorry, the square root of 100, I gave it away. Yeah. So it's like this, it's 10 times 10, right? So you have a group of 2. And so you end up with the square root of 13 over 10, okay? Over 10. And that's the answer, okay? So I want y'all to go ahead and start on 3B, and let me give you a little time on that one, okay? Ladies and gentlemen, when we simplify it, we split it into 2 radicals. And I think in general, y'all did pretty good from what I saw. This is just going to be like this. This is a prime number. So, you know, honestly, it's not going to change. Just like, that's just what it is. And there's no second 7, so it can't pop out. This has 2 x's, x times x. Well, there's a group of 2 of them, right? Because we have an index of 2. And so we have a group of 2. So out pops an x. If it's out of the radical, we don't need a radical, right? And this will be our final answer. Please notice how all of these answers, you never see a radical in the denominator, right? And that's kind of a rule, is that you can't have a radical in the denominator. So I'm going to show you how to get the radical out of the denominator, okay? I'm going to do this tough one, and I'm going to let you do the easy one, okay? So basically, if I multiplied by 1, would I mess up the value? No, it stays the same, right? Okay. So, and anything divided by itself is 1, right? So this is what you're going to do. You take your standard, what you got, and I'm going to multiply on the bottom by the same exact thing. I'm essentially giving it a partner, right? So like exit to pop out of the radical, right? But in order to make sure that I'm multiplying by 1, I'm going to also have to put that same thing on top. Yes? Okay. Now here we go. We have a radical, big radical. Everything is under the radical. I don't see anything that's outside of the radical, right? So everything's going to be under the radical. I've got 2 times 3 times b on the top. And on the bottom, I have 2 3's and I have 2 b's. Is anything going to pop out on the top? No, I don't see any partners. 2 times 3 is 6. 6b. And on the bottom, what's going to pop out? I got a group of 3's. So 3 is going to pop out, right? And I got a group of b's. And so the b is going to pop out. Good, 3b. And ladies and gentlemen, I don't have a radical on the bottom anymore. And we are done. You see how that works? This is called rationalizing the denominator, getting rid of the denominator on the bottom, okay? So you're welcome. I saved you a nice, easy example. Go ahead and give it a whirl for this. My hint would be, please notice that the 5 is not under a radical, okay? That's your hint. Go ahead and start. All right, welcome back, ladies and gentlemen. What we're going to do is we're going to multiply, and we're going to create a fraction by using the denominator and putting that on both the top and the bottom, okay? So here we have 5. We're going to create a brand new fraction. We got 5 times the square root of 7. And on the bottom, we have the square root of 7 times the square root of 7. So we end up with 5 times the square root of 7 over, notice how 5 was not in the radical, right? So you can't just place it underneath there. And over, you have a big giant radical with 7 times 7. That pair of 7s means that it can pop out, right? And you have 5 square root of 7 over 7. And we are done. Thank you so much for joining me today. You have a beautiful day. Take care.